Hello and welcome to this video tutorial on unit conversions. In this module we will be looking into the relationships between units and how to use these relationships to set up conversions between units. There is a Windows Scientific Calculator displayed on the left to show how measurements are entered and mathematical operations performed so we can determine the final answer in each conversion. Before we get started on some practice problems, let's review some strategy steps to remember when looking at unit conversion problems. First, always figure out what measurement and unit you are given and what unit you are seeking to convert to. Next, find the conversion factor that will allow you to go from the unit you are given to the unit you are seeking. Now, keep in mind that this might involve using one or more conversion factors. Be sure to figure out how many steps this involves before starting your actual conversion. Lastly, perform all your mathematical calculations involved. With your conversion factors, any numbers located in the numerator are going to be multiplied, while all numbers located in the denominator are going to be divided. Let's start off with a conversion practice problem. The measurement is 3.89 kilometers, and we are looking to convert this into inches. So, how many inches are in 3.89 kilometers? So first, we look for a relationship between kilometers and inches. This is a metric to English conversion, where meters is our metric unit and inches is our English unit. There is no direct conversion factor that relates kilometers to inches on our yellow sheet, or in most textbooks. Instead, we will have to use two conversion factors to go from kilometers to inches. One relationship we can use is that there are 1,000 meters in 1 kilometer. This allows us to go from our given unit of kilometers and convert to meters. Next, we find a relationship that will allow us to go from meters to inches. The conversion factor found is 39.37 inches equals 1 meter. Using these two relationships, we start our setup with our given information of 3.89 kilometers and use our first conversion factor to go from kilometers to meters. Since kilometers is the unit we are starting with and want to get rid of so that we can change over to meters, the unit of kilometers is located in the denominator while the unit we want, meters, is located in the numerator. So 3.89 is multiplied by 1,000, where our units of kilometers will cancel. Now, since the first conversion will give us our quantity in meters, we can then use our second relationship between meters and inches to perform our second conversion. Meters is the unit we want to get rid of so that we can change over to inches, so the unit of meters is located in the denominator, allowing this unit to cancel, and the other unit, inches, located in the numerator, is the unit we are converting to. With our entire setup written out, we can now perform all of our mathematical operations. We entered 3.89 and multiplied this by 1,000 earlier, since 1,000 is in the numerator. Now on our calculator, we multiply by 39.37, since it is located also in the numerator. There is no need to divide, since both numbers in the denominator are 1. Our calculator answer that we get is 153,149.3. We switch this to our final answer by determining how many sig figs are allowed. To do so, we look at all measurements involved and their mathematical operations. Both operations are multiplication. Based on sig fig rules for multiplication division, we look for the measurement with the smallest number of significant figures. And there is only one measurement number given, 3.89. The other numbers are part of conversion factors. Remember that conversion factors never limit the number of sig figs in the final answer. 3.89 contains 3 sig figs, so this is our limit. We make the cutoff point after the third sig fig in our calculator answer, which is 3. The first number after this cutoff is 4 or below, so there is no need to round up our last sig fig. The final answer contains the numbers 153, but also has to be expressed so that we make sure it is in the proper size or magnitude. The calculator answer has the first sig fig in the 100,000 place, so we need to add 3 zeros after the sig figs in our final answer so that we keep the size of the final answer in the 100,000 place. Our final answer then is 153,000 inches. The next conversion problem given has a volume measurement of 5.50 times 10 to the 5th liters, and we want to convert this measurement to milliliters. Again, we established our relationship between the two units. Liters and milliliters are both metric units, so there is no need to look for any English to metric conversion. All metric conversions are based on powers of 10. The given unit of liters is the base unit for expressing volume and has a value of 10 to the power of 0, while the unit we are looking to convert to has a prefix of milli. This prefix lets us know our power of 10 is to the minus 3 power. In going from 10 to the 0 to 10 to the minus 3, we are taking 3 steps in our powers of 10. In other words, the number of steps is the same as the difference in the exponents. In making our relationship, our starting unit, liters, is given the number 1, while the unit we are converting to, milliliters, is assigned our power of 10. Now we look at our units and determine if our unit is getting larger or smaller from the conversion. Since our unit size is getting smaller, going from liters to milliliters, our power of 10 exponent gets bigger. Since we are going in 3 steps and need to get bigger, milliliters is given 10 to the power positive 3. So our conversion factor is 1 liter equals 10 to the power of 3 milliliters. Now that we have established our relationship, we can now set up our conversion. Our conversion factor is arranged so that the unit we want to get rid of, liters, is placed in the denominator, while the unit we want to change to, milliliters, is placed in the numerator. Units of liters then cancel, and we are left with the measurement in milliliters. Here's how to perform our mathematical operations on the calculator involving measurements expressed in scientific notation. To enter 5.50 times 10 to the 5th on the Windows calculator, we first enter the coefficient 5.50, then hit the EXP button. EXP essentially enters times 10 to the power of, so now all we have to do is enter the exponent value after the E that is now on our calculator. We do this by simply entering 5. Now that we have the given measurement entered on our calculator, we can multiply by our conversion factor. For entering 10 to the power of 3, we do the same approach as before. Since there is no coefficient in front of our power of 10 in the conversion factor, this implies a 1 be used. So we enter 1, then EXP, then 3. Our calculator answer is 5.50 times 10 to the 8th. This answer can also be reached by simply adding the exponents, since this is a multiplication done on powers of 10. The last practice problem for this tutorial is a measurement of 240 micrograms that needs to be converted to kilograms. So the first thing we do is to establish our relationship between the two units. Microgram and kilogram are both metric units, so there is no need to look for any English to metric conversion. Remember, all metric conversions are based on powers of 10. The given unit of micrograms has the prefix micro, which corresponds to a value of 10 to the power of minus 6, while the unit we are looking to convert to has the prefix kilo. This prefix corresponds to a value of 10 to the power of positive 3. In going from 10 to the power of minus 6 to 10 to the power of positive 3, we are taking 9 steps in our powers of 10. In other words, 6 steps to go to 10 to the power of 0, and then another 3 to get to 10 to the power of 3. In making our relationship, our given unit, micrograms, has the number 1, while the unit we are converting to, kilograms, is assigned our power of 10. Since our unit size is getting bigger, our power of 10 exponent gets smaller. Since we are going 9 steps and need to get smaller, kilograms is then given 10 to the power of minus 9. So our conversion factor is 1 microgram equals 10 to the power of minus 9 kilograms. Now that we have established our relationship, we can now set up our conversion. Our conversion factor is arranged so that the unit we want to get rid of, micrograms, is placed in the denominator, while the unit we want to change to, kilograms, is placed in the numerator. Units of micrograms cancel, and then we're left with the measurement in kilograms. So here's the setup for our calculation. 240 micrograms is multiplied by 10 to the power of minus 9. And the answer we get is 240 times 10 to the power of minus 9. This answer, however, is not in correct scientific notation form. In order to get a coefficient number that is between 1 and 10, the decimal needs to be moved 2 places to the left. In doing so, our number becomes smaller, so that the power of 10 exponent will become larger by 10 to the power of 2. The exponent is changed from 10 to the power of minus 9 to 10 to the power of minus 7. Now that we have our coefficient between 1 and 10, the last item we need to do is make sure we have the correct number of significant figures. The operations involved are all multiplication, so we look for the measurement with the least number of sig figs. The only measurement we have is the info we're given for the problem. 240 has only 2 sig figs, as the trailing 0 does not have a decimal in the number, so this 0 is not significant. Since we only keep 2 sig figs in the final answer, 2.40 turns into 2.4. So our final answer is 2.4 times 10 to the minus 7. Thank you for watching this tutorial. Hope it's been helpful. Feel free to replay this tutorial at any time to review content.